on to the next theorem. Theorem 5, the alternate segment theorem. Alternate segment theorem. So don't get confused with all these theorems. You can always go back to check back. Well, for this theorem, we need a tangent. And so we have a tangent. What else do we need? We need a triangle. A triangle where at one of this vertex meet the tangent. So the vertex of this triangle. So this a triangle has 3 vertices. One vertex here, another one here, and another one down here. Okay, so I'm gonna start so we can organize this one. This one's a little challenging. Usually it's the most challenging one actually, but some people don't see it that way. They think it's the easiest one. Well, if you find it easy, then that's really good. So we have a point A here, we have point B here, and you have point C here. So what we have is a triangle with one of its vertices, well, one of its vertices meets the tangent at this point, the point of tangency there. So what is this theorem about? Well, let's move on to see what it's telling us. Okay. So that this angle here, that is between the tangent and this side of the triangle, we call it a chord. So the angle between the tangent and the chord is equal to what? This angle over here. So we're still on the alternate segment theorem. Alternate segment or alternate angle theorem. Okay. And this angle here will match this angle here. Okay. Alternate segment theorem. Okay, so let's go back a little. Okay, so let's set it up. It's a little practice. So we have this point here, A. Think of this as angle A. Think of this as angle C. And think of this here as angle B. All right, based on what you looked at a while ago, if I should put an angle, let's change the color quickly. If I should change the color, okay, well, if I should look at this angle here, okay, I'm definitely gonna need to change that color. Let's use white. So we look at this angle right here. And let's call this angle 75 degrees. Can we determine the angle B, C, or angle A? Well, based on the alternate segment theorem, we learned that the angle between the tangent and the chord, so this is a chord AB, from point A to point B is a chord. The ends of this straight line touch the circumference. Angle between tangent and chord is 75. We learned that this angle is equal to the angle in the alternate segment. So if you look at this chord here divides circle into this segment and this segment, this major segment over here. And which angle is in the major segment over here? This angle actually right here. So this angle is actually the 75 degrees. That angle is actually 75 degrees. If you think about it a little, that's where that's coming from. Okay. So now let's look at another point in that. As mentioned before, that's one of the most challenging. So what angle, if we have this angle to be, let's say this is 60 degrees, the angle between the tangent here and the chord AC is 60 degrees. What angle can we determine? Well, again, this chord here, whereas 60 degrees, that's between the same chord and the tangent, should be equal to the angle in the alternate segment to this segment here. So this segment here, so this chord AC divides the circle into two segments, the minor segment, and everything over here will be the major segment. And so this angle here will be in the major segment. So this chord divides circle into the minor segment, and over here with the major segment. Okay? So if this is 60 degrees, the angle between the tangent and the chord is equal to the angle in the major segment. So this actually is 60 degrees. Give it some thought and you